I think to some extent, knowing what you don't like might be just as important as knowing what you do like. And you can steer yourself in that sense. It also gives you the opportunity to try lots of stuff. Because you might think you want to be a biologist, but if you take an anthropology class, maybe you love anthropology. Or chemistry. I mean, it could be chemistry, it could be some other type of science. But I knew I wanted to get into science.
There's a picture of you on the website with looks like you're down in a cave, or what was the occasion of that?
A lot of the work I do is on fossils in caves. And I'll show tomorrow some of that work. The one that I have the hat on is this cave. It's called Samuel Cave. It's in California. It's just, on California you have the Coast Ranges, and then the Central Valley, and then the Sierra Nevada. So the cave is actually, if you look at the point at which the Central Valley is the most northern point, that cave is just north of that in the mountains as you get into Oregon. And the cave was initially excavated in the early 1900s because they were looking for humans. And there was a story, I'm going to tell this, you're going to hear it, you'll hear it now, you'll hear it again tomorrow, because it's an awesome cave and it's an awesome story. They went into the cave because there was a Native American story that said that the tribes that used to be around there, the young men would go into the cave and there would be sacred waters that they would kind of splash on themselves, and they would come out when they were a certain age. There was a story that said that there was these two women that went into the cave and wanted to find the special waters that the men were allowed to go and touch, and so that they wanted to do it. And they went into the cave, and as they were exploring the cave, they fell into a giant pit. One of them did. One of them came out and told the tribe, and it became a cave that had kind of a bad omen to it, and it was hard. It took us a long time to get permission to excavate in the cave because it still had this bad omen. But when they went to excavate, when you get to the cave, there's an opening that you can stand in, but then you walk in about 15, maybe 10 yards, 30 feet. By the time you're in the back of the cave, there's a small opening that you can barely kind of fit yourself into. When you go through that small opening, you can make a left or a right. Well, if you make a left, what we were told is to kind of get on our backside and scoot ourselves, and there's a blind 4-foot jump. You kind of just have to trust that it's a blind 4-foot jump. And you go, and it's awkward, but you're looking up and you kind of fall over and you land on your feet. Well, if you make a right-hand turn, you walk about 10 yards, and then there's a 100-foot pit. And when they first went there in 1903, they went to the bottom of that pit, and at the bottom of the pit, there's a woman's skeleton at the bottom of the pit. It was kind of awesome. And then that woman is probably a few hundred to a few thousand years old, not more than that. So it wasn't, they were looking for the first people in the US. But they did an excavation there. When they excavated the animals there, they found lots of extinct things and lots of small animals. And so one of my projects was to date those animals, and they dated to around 20 to 22,000 years old. We went back. This was another woman that I worked with from Stanford, and she found a different part of the cave that was near the entrance that you had about this much. Here's the floor, and then the wall of the cave is about this high. And you crawl on your belly through this for about 30 feet, 40 feet. And then it comes into a little opening that you can fit 2.5 people in. And she found fossils there, and we dug them out, and I dated them. And they were about 1,000 years old to modern. And there are similar animals, similar small animals as we found in the big cave. So we had this small animals that were 22,000 years old when it was really cold, and small animals that were 1,000 years old when it was warm. So we have a comparison of climate change. 20,000 years ago was cold, 10,000 years ago was warm. So that picture is us excavating. I was only there for a week. You'll see it tomorrow. It's us excavating these fossils out. We did a project of what does climate change do to body sizes in small mammals at this particular cave site. But a lot of the fossils I worked on come from caves. And the other thing is I never knew I was going to get into kind of going into caves, and I'm not claustrophobic, and I love it. And you get to go crawl through sheets, and the key is to let somebody go first. I'm more worried.
That
like,
way if you hear them go, ah!
yeah. And it's more for, like, I don't want to find a porcupine in the back of a cave somewhere. Like, I don't want to be the first person to go, hey, Mr. Porcupine, how's it going? And that's what I'm not worried about getting stuck. I'm not worried about, like, things falling in. It's more of, like, what kind of animal am I going to corner that's going to be really mad that you can't get out. But it's been a lot of fun. And the hardest part about that was once you dug the fossils out of this part of the cave, to get it out, so you have a small, we couldn't use 5-gallon pails because that was too tall. So we had to use 2.5-gallon pails. And to get them out, so we have 40 feet to go, is you gotta go on your backside. So you're staring up and you're kicking the bucket in front of you for 40 feet. So you kick the bucket a few feet ahead of you, and then you move, and you kick the bucket ahead of you, and you move. Just to get the fossils out, the dirt out, that you could then look for the fossils in the dirt, which is kind of funny.
Seems tedious.
Yeah. Yep.
Is a lot of your work outside, like doing things like that, or mostly just inside?
No, most of my work is, most of my day is sitting in front of a computer, and it's looking at papers, looking at data, writing papers. I would say I spend 4 weeks a year outside, which is more than most people get. But the nice thing is it's in awesome places, right? I get to go to California and dig in California. I was able to go to Spain. I've been digging in Spain since 2007, and I've gone for the longest amount of time was 3 months, a couple weeks. I went for 2 weeks last September, so that's completely outside. Where I dig is it's a collapsed cave, so that it used to be a cave that was a hyena den, and the hyenas would go out and collect animals to eat and bring the bones back in, and they deposited the bones in the cave. It's outside because the roof collapsed, and so the bones are now exposed at the surface. And a couple of years ago, they basically give me the same square to dig. It's a 1 meter by 1 meter square every time I go back. And over the course of 2 weeks, you only dig about this far, and you're slowly digging a hole. But you find elk. They're the species that then becomes domesticated cattle. It's called Bos primigenius, or they're called aurochs. They're what becomes cattle. Find those, lots of hyenas. In the square just behind me, they found 2 Neanderthal teeth a couple of years ago. So, which means that the hyenas went out, grabbed somebody. They don't know if he was dead already, but probably not. Brought him back to the cave and had a Neanderthal meal. So it's some is outside, but the outside is it's fun.
2-part question. One, how long would you say you've been doing like what you do now?
I consider my beginning of my master's degree when I started, so that was 97.
Okay. So like, how do you think the advances of modern technology have changed your work and how you're able to do things?
That's a good question, and a lot. And so I was trained as a master's student to look at the chemicals. When we first started, how I was trained, and it changed even when I first started, is we would take a horse tooth and a hammer and smash it. And so curators at other museums would like, you're a geochemist, we don't want you here. And because you would take a tooth that they took a long time to excavate and take a hammer and take out the enamel part of it. So your tooth is enamel indented. Horse teeth have a different pattern where the enamel and indentin are kind of intertwined. I really need to look at the enamel because it's a very solid material. So you took a hammer and you smashed it, and I needed a half a gram. The machinery has gotten so good now that I now use a drill, and I take off 5 milligrams, which is, I mean, dust. I mean, it's this, that's 5 milligrams. So the amount of material that I use and the technology's gotten so good with the machines that we're using that everything's, a lot of it is automated. So things are getting more and more precise, and we're using less and less material. And the same thing with carbon dating. With carbon dating, you used to take a piece of bone, you stick it in the chamber for a really long time. And now we take, I've done something, if you can get, things are about 50%, if I took you and this is kind of gruesome. If I burned you, you're 50% carbon. Everything living is about 50% carbon. I need 50 micrograms of carbon to get a date off of. So I need 100 micrograms. So I need that in carbon to get a good date. And so the technology's gotten so great that we just use less and less material. And it's been good because now one of the things that we just studied is there's these humans, and I'm not going to show you this tomorrow, but there's this pit in Spain where they dumped 28 individual humans. And we were curious about looking at the ecology of these humans. And instead of using a drill or taking a hammer, we can actually now use a laser. And we zap the teeth with the laser, and it makes a little crater, but it's not destroying the overall kind of shape, what we say the morphology of the tooth. So we're using the technology to benefit. And so you have the shape of the tooth still there, but we're getting the information out that we really need to get the information out.
What do you look for in the bones and the teeth to determine like what kind of animal it is or whatever?
So to determine, I don't do DNA. So you do DNA analyses to figure out particular species. Most of the work that I do is geochemical chemistry. But a lot of it is knowing differences in the morphology and the shapes of things to figure out what the animals are. So if you took out a deer skeleton and gave me a piece of that bone, if you gave me a piece, that's easy. That's like a whole bone, that's fine. The hard thing is when you get a cracked piece, is like, what is this? It's over time, you learn, and you have to spend the time with the material. And if you're interested in it, you can take classes on, it's basically osteology classes. And if you see it like CSI shows with people, that's basically what it is. It's just not with people, it's with animals. So if you find a piece of a finger, those people can actually tell that it's a piece of a finger, it's a piece of the right side or left side, because there's subtle differences. So we found a seal. New York State was covered with ice, and then the ice melted. So if you carry a bag of ice, it's pretty heavy. I mean, an 8-pound bag of ice is pretty heavy. An 8-pound bag of ice sitting on the ground is only this big. The center of New York had 3,000 meters of ice on top of it. So just imagine how heavy that was, and actually pushed the ground down. And it melted back so fast that portions of New York State, where Lake Champlain is now, was under sea level. So instead of the river flowing out, you have the Atlantic Ocean flow in. So we find whales and seals, because it took a long time for that ground to rebound to sea level. And so for about 4,000 years, there was marine animals in New York State just swimming around. When we found a seal a couple years ago in clays, and we were trying to figure out what is it. I'm not a seal expert, so you take the bones and you go to another museum and say, I need all your seals. And you lay them all out and you say, okay, what are the different features? And luckily we found the jaw, and I was like, okay, usually jaws are the pieces that you need. There's a lot of features on teeth, a lot of features on jaws. It turns out that the tibia, your shin bone, is what actually helped me diagnose